So let's start with today's topic, and it's concurrency. And before I'll go there, I'll just give whatever Ankur has just told about me. I'll just show you on one slide. So here are my contact information, my website, and you can mail me on contact@dheeraj.com. You can connect with me on LinkedIn and Twitter. So I'll come to next slide, and this is the things which we will discuss today. So we'll start with concurrency, and we'll see what's the difference between concurrency and parallelism, and concurrency and with process and threads, what happens, what is process, what is thread. We'll go with that, and then some why to use concurrency and what's the cost associated with that. After that, we'll jump into a code section, and we'll see lots of code and lots of C++ classes and terminologies, and we'll discuss some common pattern in concurrency, uh, concurrent environment. So what exactly a concurrency is? So it's a ability of your computer program system to perform multiple tasks simultaneously. You can say in parallel. So you can achieve by doing different part of your program or system to run independently of one another without interfering with each other's execution. So parallelly, two things can run. And concurrency can be implemented with different techniques. Okay, so you can use threads, processes, coroutines. It is introduced in C++20, so you can use that. And it often improves your performance, responsiveness of your program, and you can scale your application. Okay, so it's actually, in short, you can say it will improve your performance of your program, and you can do multiple things. And obviously, we know that if we can do multiple things at the same time, obviously, it will improve. So there is another term with concurrency. We use parallelism, and it's quite used interchangeably. But actually, these two terms are not same. As I said, concurrency refers to the ability of your program to have multiple tasks in progress at the same time. This often achieved using multi-threading and multitasking. So just for an example, you can visualize that there are web server and you are handling multiple requests at the same time. So that is a concurrency. On the other hand, parallelism is ability of a system to perform multiple tasks simultaneously. So it requires your multiprocessors, means it requires multiple processors or multiple cores. Okay, for example, a parallel program can break a large computation into small chunks, and you can run them differently on different processors. So in parallelism, you have different CPUs, you have different cores, processors, and your application use that hardware to run your code, run your code piece. And in concurrency, it may execute on different core, but it's a software part, and that your OS take care of that running, switching between threads and all those stuff. Okay, so this is a basic difference between concurrency and parallelism. And so now when we talk about concurrency, so there is a way, means we can achieve that with multiple processors, right? So you can divide your application into multiple single thread processes, which can run simultaneously on your system. This is similar to running multiple programs at the same time, such as means you run your web browser and you run your Microsoft Word, something. However, communication between these processes are difficult and slow due to OS provides some protection around your processes. Sorry. And additionally, there is an overhead associated with your with your multiple processes, such as you have to start your process and utilize resource management. So despite of these downside, using separate processes for concurrency also has advantage of being able to run the process on different machines connected. So you can have different processes on different machines also. So that usually we use this kind of concurrency in networking applications. So you run from one application on one and other is application of other. So that is also concurrent, because concurrently you are running two sections of your application. Another way is to achieve this is you utilize threads which are within a single process, and threads are lightweight processes in that they each run independently and execute different commands. However, all threads within a single process, they will share same memory space and allowing easy access to shared data through a global variable or passing pointer or reference with a different way. Okay. And memory space which threads are sharing, and there is less protection, OS protection on these threads. So with compared to processes, there are less administrative works OS need to perform. So these are very easy to use and invoke. Okay. But at the same time, when you are using threads, it is giving you lots of flexibility, but at the same time, it's your responsibility to ensure that consistency of data, which is shared between multiple threads. So you'll have to use some mechanism to keep that data consistent and share efficiently between threads. Now the point comes, this is one question, that why actually we use concurrency? Why can't we do in as a single thread application? So obviously we are talking about it, and I already said that you can run multiple tasks at different multiple tasks at the same time. So there is a separation of concern that you will group some piece of code and you will say, okay, let it run independently, and you will there will be some other code which will do some other activity. So maybe one thread is writing collecting some data and pushing it into database, and other thread is reading from database and it is doing some calculation, and these two are independent activities. You need not to be blocked, so you can use that. Okay. And this will obviously improve your performance, because you have two things to handle your data. So let's say you have lots of traffic coming in. So your thread, data collector thread, it will collect all the data and it will push it to, and you have some other thread which is at the same time it is. So you can serve multiple requests very efficiently. So in this way, it will improve your performance of your application. But with this, there are some costs associated with your thread. So when you use concurrency in your application, okay, so this will make your code little complex, and as your code will grow, it will be hard to maintain. So you will have to take care of that at every time, and that may lead to some bugs. So, and it's very difficult to, well, I'll not say very difficult, but it's difficult to debug a multi-thread application. So be careful when you are using concurrency in that. And then there are overheads associated. Overheads associated means you will have, means your kernel will have to invoke a new thread and allocate some stack over stack spaces, and then scheduler will come in picture to efficiently schedule your threads. So all those things will also come into picture with your thread. So it doesn't mean you spawn thousands of thread and it will improve your application performance x means multiplied by 1,000. No, it's not like that. So you will have to be little careful when you are using that. And again, that is scalability, because you have multiple thread, how you will scale, how you will handle so many threads. So that design and coding, all those activities will come into this. So far we saw and we discussed the basic concept why we use concurrency. Now let's jump into a real code, how you will use a thread in your application. So we'll start from very basic. And this is a very basic program in which I am using this standard library has introduced that thread library. C++ standard has that, and it provides this standard thread class. And you don't have to do too much of work. Just you will create an object of your thread, a standard thread, and you will pass a function which you want to run as a thread. That's all. So in this small program, now you have two threads. One is main thread, another is which we are creating at line number 10. So you are just passing a function and your thread is created. Okay. Now there is another way, means you can use any callable type. Callable types are like you can use function, you can use functors, okay, function objects. So your thread class will allow you to pass any callable types, and you can pass it to your thread class constructor, and it will create a thread, okay, using that type. Okay, so here you see I have a class, a background task at line number 8, and I have overloaded this parenthesis operator of this class, and now I'm creating a thread using this. Now this background task class, this is a callable now, and I'm creating one object and I'm passing that object to my thread constructor, my thread class object constructor, and it will create a new thread. Okay. Now let's see if I don't want to in this you see at line number 20, I have created one object of background task. Now I don't want to create that. Okay. What I did is I passed a temporary object of background task to my thread. And just for clarification, background task is just, I'm using just a name here. It's not like something running in background. It's actually a task. You can do anything inside this background task. Okay. So here you are passing one temporary object. Now, can someone identify, is there any problem, any issue with this line number 21 in this code? I'll take a pause and wait for someone to identify.
Probably it's not a callable.
Which one you are saying, not a callable?
Background task, right? Like it's already calling the function. Like my thread probably will take the callable object or function, but since we're already calling background task, right? It's a function call kind of thing. I believe just it will result in a compilation error.
Yes, this will result into a compilation error, and so compiler will treat this line as a function instead of treating it as a object of thread class. It will take it as a my thread is a function which is taking background task object as a parameter, and it will return standard thread. Compiler will treat it like this, and it will give you a compile time error. Okay. Anyone is speaking?
This should call the constructor, right? And then the object is callable.
Object is this background task object is callable. Okay.
Yeah.
But
and then
this whole line.
And this should
So
call the constructor.
Actually, this will not call a constructor of your thread class. Okay. This will treat it get treated as a function. So I don't know. I'm missing that term. Actually, that term is very explanatory.
You want to say function declaration? It looks like it looks like a function declaration where that first token std thread is the return of the function. And
yes, so Ankur, there is one term which we use for this, right? I'm
the most
that
vexing
term.
parse, the vexing parse.
Right, that more. Yes, yeah. Yes, that's what. So that is the reason why this will get treated as a function.
If you do a function operator, will it work or not?
Sorry?
Function operator. If I use now function operator, background underscore task, parenthesis, after that also parenthesis. Will it work or it won't work?
Yes. So, so that is what I'm coming to. So now, if you will add an extra parenthesis around this, now this will get treated as an object of your thread class. Okay. And there is another way you can be sure that it will always get treated as an object, and which nowadays for many years I'm using. That is called uniform initialization syntax. You can use that and you will not get any issue, these kind of issues. So use your curly braces instead of parentheses to initialize your objects. And this will, so at line number 20, it will create a thread with the background task. Okay.
I'm still not able to get the reason why. Can you? So the extra parenthesis, so is it like deferred, or I mean, why the extra parenthesis works and then direct?
So
yeah,
maybe right now I don't have
I can add
answer.
a statement here. Yeah.
Yeah.
So basically, if you see from the compiler point of view, in the first syntax, compiler is not able to distinguish between like whether you are trying to declare a function or whether you are trying to create an object. Syntactic, right? Syntax wise, it is not able to identify that, because if you try to write a function declaration, as of now you are seeing that inside a main function, so that's no, you know that okay, this is an object. But if you try to write, let's say, a function, let's say if I ask you to write a function which takes an object of background task and return std thread, you will most probably write like something the way which is written on line number 21. So compiler is not able to find out. So what they have added to distinguish these two things, right? In earlier days when the uniform initialization was not available, that if you add that parenthesis, then it will treat as like, okay, this background task is a kind of an object, and then you are passing that there, so that basically compiler will be able to distinguish. So that's what they have added. And with uniform initialization, anyhow, you can't declare a function using curly braces, like you need to use the normal basis. So the compiler is able to distinguish. So it is just the compiler parsing which is a problem here.
So anyhow, so if it was a function declaration, so the arguments must be a type, right? And whatever we give inside the braces. So now here background task constructor call is not a type. So anyhow, it should be able to distinguish, right?
I will suggest so. I mean, instead of spending time on most vexing parts, I have just posted a link here. So you go through that. There are a lot of nitty-gritties
Okay.
there in the grammars of the parsing. It is one of the complex language, and the grammar is also complex. That's why this
Okay.
issue comes
Okay.
there. Okay, yeah.
Maybe we can
Thanks.
utilize
Declare
our next
offline. Yeah,
next talk, that fireside chat, and we can also discuss there. Yeah.
Okay.
Okay.
Thanks.
So yeah. Okay. So we were here, and now the another way we can create a thread is we can use lambda expressions. Okay, and it's simple. It's same as lambda expressions are introduced in C++11, and we can directly pass our lambda function to my thread object, and it will create a thread. Simple. Now we talked about creation of threads. Okay, but once you have created a new thread, it's your responsibility to decide whether you want to join that thread to your main thread and or you want to keep it running independently. Okay, and if you are not making that decision before your standard thread object is destroyed, your program will terminate. Okay, so always keep in mind that you will have to make that decision before your std thread object is finishes or get destroyed, and it will not matter whether your thread is still running or not. If your thread is running, that is fine. If your thread has completed your the execution, that is fine, but you'll have to join before your my thread object in this case goes out of scope. Its destructor is getting called. Before that, you will have to join your thread. Otherwise, 100% this will crash. Okay. So joining a thread means your main application is waiting for your thread's completion. Okay, so your main thread will wait till your thread is your other thread which you have created and you are joining here, that gets completed, and your main thread will be blocked till that time. Okay, and it's important to note here that thread can only be joined once. After it has been joined, it will be considered as non-joinable. And joining a thread ensures that thread has completed its execution and all the resources which this thread is owning are freed before main thread continues. So you'll have to take a call where you want to join. If you have multiple things you are doing in your main thread, so you'll have to see where exactly you need to call a join because as soon as you will join, your main thread will get blocked. It will not execute further. It will wait there till your thread is completed. So these things you will have to take care of when you are writing a thread and using this concurrency. The other thing is you can leave your thread running independently of your main thread, and your execution state means your thread, how it is is it running or not, it will not be tracked by your main application. It means by default it will not be tracked. Means you can track that, you will have to put some extra code or something, but by default it's not, it will not. Like in case of join, it will wait, so it will not wait here. And your program, your main thread will not be blocked. You can run your both threads independently. And if let's say your main thread completes its work, it will exit, but your thread which you are running as a detached, it will continue running till the time it will complete its execution. And once it will complete its execution, that thread will complete. It's your responsibility now as a programmer to clear all the resources which you are using there. Okay. So if you will not do that, those will be those resources will be wasted. Okay. So usually detached thread, when you want to run some daemon activity, or let's say you want to check you want to run a status check, you can use these detached threads, which will not impact your main application. Okay.
Dheeraj, could you
when
go
you are,
back to the previous slide? I had one doubt here.
Yeah.
You said resources used by the thread will not be freed automatically when the thread finishes execution. The programmer needs to handle it. So are you trying to say that whatever callable object I'm passing, so for example, if I'm passing a class, the destructor of that class needs to release all the resources that it has been holding?
Yes.
Am I understanding correctly?
Yes.
Okay, so thread will clean up its own resources, but not the callable objects resources.
Own resources means stack and all those things it will clean, but let's say you have allocated some memory, so you will have to take care of those things.
Understood. Yeah, thank you.
Okay, so now when you are running a detached thread, there is a few cases where you may get some issues. So let's say you are if you see in this code at line number 18, I'm creating one local variable and I'm creating my object, thread struct object, and I'm passing this local variable and storing it as a reference. Okay, so at line 6, there is a reference where I am storing this local variable, and then I'm creating an thread using this object, and now I'm detaching that thread. So when I'm detaching this my thread here, my thread will execute in background or parallelly. It will continue, and this thread function will exit gracefully, and it will clear all its local variables and everything. Now the issue here is in your thread, in your my thread which you have created there, you are actually referring to the local variable which you declared at line number 18. You are referring that object, but actually that is not valid now. So you have some random memory location now your thread is referring to, and when you will use that reference variable at line number 10, it will be an undefined behavior. Means your application may work, but you cannot guarantee that. So you need to be careful when you are passing an variable to your objects. So it's one way is you pass it as a copy instead of reference. You don't take it as a reference in your thread, and there you will make a copy of it, and now if your thread function will go out of its scope, it will complete its activity, but still you will not have a dangling reference. You will have your own copy and you can use that. Okay, with this, there is another thing which I want to point it here is, let's say you are joining your thread. Now we discussed about detached. Now you are joining your thread in this program like this, and you have some activity, you are doing some activity, you joined your thread at line number 14, but you have some code which may throw some exception, and you added one try catch. It's very good. Your code will work if it's fine, but when your code which is in try block at line number 9, that wonderful work whatever you are doing, if there is some exception coming out from that code piece, your application, your flow will go into catch section where you will handle your exception. And from there, your thread will exit because you will handle it and gracefully it will exit. All good. But now the point is, at this point, your thread is not joined in catch section at line number 12. You are not joining your thread, which will means this will result into a crash in your application because your thread is going out of scope. My thread object is going out of scope, but it's not joined yet in case of exception. So what you can do here is you can add a join statement in this catch section. So now you are handling both cases. If it's a graceful execution, your thread will get joined at line number 15. But if it's a exceptional case, then your thread will get joined at line number 13 and it will gracefully exit. Good. But if your code is growing, if you have 10,000 or 1 million lines of code, in those kind of codes, it's very difficult to handle or keep that, or it's someone else's code. So you will have to be very patient in finding the places and doing everything right. So what what the other solution can be is you create a thread guard class, and inside that, it's in the thread guard class constructor, you will join your thread. Okay. And when you are creating your thread, so at line number 21, you are creating your thread, you will pass it into your thread guard. Now this thread guard will take care, okay, this is a object now, that local object, and whenever this will go out of scope, this thread guard object, its destructor will get called and your thread will be automatically joined to your main thread because you are doing that in, if you see at line number 8, you are doing that. Now you don't have to worry whether you have a graceful execution or there is an exception. It will be taken care of with this. Okay. So far, any question? And by the way, this is also called as a your RAII, resource acquisition initialization, because when you are allocating that resource and you are clearing that also. Okay, so now we'll move to the other section, which is how we will pass some variables or parameters to our thread. This is a simple simple thing. You are passing.
Dheeraj, just one
Yeah.
question. So will it be slow compared to the thread join if we use thread guard?
Obviously, there will be some trade-offs, but I believe slowness is better than crash.
Yep.
So there will be some impact.
Oh, yeah, thank
you. Okay, so yeah, here in this program, you see I'm passing a character buffer to my thread. Now, what happens when you pass any parameter to your thread object? So by default, all these arguments are copied into internal storage. So it will be a direct copy. Okay, and your thread can access these variables, these parameters. Okay, newly created thread can access that and then passed to the callable object. So once it is copied, once your thread object will copy all these as a it will copy, it will not take a reference, it will copy, and then to your thread it will passed as a R value reference, R values. Okay, in this case, okay, so in this case you see our pointer, that local variable buffer, it is passed to the thread. Okay, and there is a significant chance that your application, this dummy function, will exit before buffer is converted to string, because if you see at line number 1, that function is taking string as a parameter, and we are passing it a character buffer. So that conversion will take place, and if your application means your dummy application will complete before this conversion completes, this typecasting completes, your application may crash. So I'll say it will be undefined behavior here. So better to do this this typecasting upfront, and before you pass your character buffer, you convert it into a string. Okay, you typecast it by your own. By this, you will make sure that there will be no conversion or typecasting happening internally, and your application will work smoothly. Okay. Now, there may be scenarios where you want to pass some parameters as a reference, okay, and you want to collect the updated values in that variable, whatever you are passing. Okay, so in this example, if you see update data, it expects the second parameter to be passed as a reference. Okay, second at line number 5. But internally code will pass it as a R value. And if you means that just we discussed that your parameter will be passed as a R value to your thread. And if you want to collect R value, you need to have here means so you need a constant reference to collect R values. Okay, because it will be a move only type. But you have integer reference, you don't have const here. So your application will fail here at compile time only, and because there is a mismatch. So what's the solution? Okay, so what you can do here is this is all the boxes which I already discussed here. So what you can do here is in C++, we have a standard reference class. You can wrap your argument with a standard reference, and it will take care of all these conversions. So actually a standard reference is a handy function in our library, standard library, which gives you reference wrapper object. And reference wrapper object is it wraps a reference as a copyable assignable object. Okay, so your object, whatever you are passing, this will be passed to your update data as a reference. Okay. Now, there are a couple of things in thread class, and one of the important thing is this thread ID. So you can use this thread ID to get to know which thread is running right now and what is happening. Okay, you want to identify, okay, this thread is running, so this is useful for logging purpose. And you also have a get ID method, which will again give you a thread ID. And if there is no thread associated, so you will get a default constructed thread ID object, which means no thread is not any thread, it's not a thread, like this thing. So far we discussed about creating a thread, how to join, how to detach, what all things we should take care of when we are creating a thread. Now, the next point will now next section is synchronization. So before I'll jump into synchronization, is there any question? Let me take a sip of water by that time.
Can I know what is the difference between concurrency and parallelism?
Okay. So concurrency is a software term, I'll say in this way, and parallelism is depending on your hardware. So just for example, let's say you have a coffee vending machine in your office, okay, and there are two queues. People are standing in two queues, and there is only one vending machine, So at a time, one person from Q1 will take coffee. It will go back. Now the turn will come to the next queue. That person, one person from second queue, it will take coffee, and like this, switching will happen. So your queue is progressing parallelly. Means means it's a time bound, you can say, or whatever, but it's happening simultaneously, not parallelly, simultaneously. But now assume you have two coffee vending machine in your office. One queue is for associated with your coffee vending machine, first coffee vending machine. Other is associated with your second vending machine. Now these two threads parallelly can progress. People can get coffee from two people can get one coffee at the same time, right? Is this clear?
Actually, the thread will be responsible for doing some. If I have a two core machine at that time, if I create a thread, who is the responsible for giving to task for the cores? It will take automatically, or we need to explicitly say to.
So we can control that. And that that thing will be out of scope right now from this talk, but yes, we can control that on which CPU or which core I want to use. By default, if you are not doing that, your operating system will take care of those things, and it will do efficiently. It will allocate available core or CPU for your processing.
That means each process will have a thread. If I have more threads in a process, can I do it for multi-core, or it will only be concurrent programming?
Means you are asking if you have multiple threads, so can my multiple threads run on a multiple cores, right?
Yes, a single process, a single application.
Yeah, single application, but you have multiple threads. So can these threads run on multiple cores?
Code.
Right. I think this is by default OS will take care of that, and if required, it will use multiple cores on multiple CPUs for that. But if you want to control that, there are ways to do that.
Thank you.
Just follow question on Dheeraj Jha, like for the controlling, right? Is there any portable way, like I mean Linux and Windows? I think probably you're referring to Affinity, right?
Sorry, can you come again?
I mean, basically like controlling the cores, right? Basically where my program should execute. I think it will be possible with the core affinity, right?
Okay, actually, I don't know that. Means by my own I have never tried that, so
okay.
I cannot say that what is the way to do that. Okay, but yes, there are ways to do that.
Okay, yeah, thank you.
Last question.
Yes, Tarun, what you said sounds right.
Okay. The coroutine and threads are same in C++.
There is a difference, and I want to suggest you there are a couple of talk happened in CppIndia to refer that. Maybe if someone can share that link about coroutine. But yes, there are differences, some differences in usability, and maybe in future we'll cover that in another talk, because this is just a basic we are going through, and we'll cover that there. Okay. Okay. Yeah. So I think now let's move to the synchronization thing. So when you do synchronization, so you are sharing some memory or data between multiple threads, and there are chances that it may lead to race condition, and which can produce something unpredictable, and there can be a data inconsistency. At the same time, there is another thing like deadlock, which we say, and in deadlock, your thread is continuously waiting. Okay, means I need this resource, but for some reason I'm not getting that resource. and your thread is blocked there, and it's blocked in there. If it is getting blocked for a longer time, that comes to starvation of your thread. So that is another problem, categorized problem, that your thread is waiting for a resource, but it's not getting, and it's just waiting. So it's a starvation. So we'll cover a couple of these scenarios in now. So let's start with race condition. This is a typical, very well-known interview question. Okay, print even and odd numbers from using two threads. Okay, so you have this print even function, you have this print odd function, you are creating two threads, T1 and T2. T1 will print even number, T2 will print odd number. All good. You have two threads, it's printing, but no, this will not give you the output. You can't say what will get printed. Maybe you will get 1, 2, and after that you will not get anything. So it's unpredictable. So you will have to, because what happening is you are having a global variable shared resource value, and both threads are running parallelly. So you will have to synchronize those. So for that synchronization, there is a standard library is giving that mutex class. You will have to create a mutex object. So at line number 2, in this example, we have this mutex object, and you will have to take a lock before you are uh, going to update your value, your shared resource. You will have to take a lock, and this will tell other thread whoever is going to take a lock. So at line number 18, your other thread will be blocked here, and it will be waiting till that lock is free. Okay, so now your thread 1 print event, this has taken lock, it will execute your its work, it will do its activity, and then next it's this thread's responsibility to unlock this thread, this mutex. And once this mutex is unlocked, your other thread will start executing. Okay, so now this mutex class, okay, so this has couple of methods, means not too many methods. It has lock, try lock, and unlock. So try lock is it will try to check, it will first check whether it mutex is available or not, and if it is available, then it will take that lock. Okay, and it's a very useful way, means I'll suggest to use this to do all your synchronization activities, and keep that in mind that this mutex is a blocking mechanism. Your thread will whoever is trying to attempt that get that lock on that mutex, if mutex is not available, it will be blocked there till the time it is available. Okay, but there is one problem in this thing. You are locking and you are unlocking. Again, think of a code which is very big, and there are possibility, we are human, there are possibility that we miss to unlock our thread. Okay, and if your thread is unlock our mutex object, and if we are not unlocking, your other thread will be blocked forever there, because it's waiting for a lock. So what's the solution? So again, in our library, standard library, we have lock guard. You can use this lock guard class, and you can pass your mutex to this. And what this lock guard will do internally is, when you are creating an object of your lock guard, it's in its constructor, it will call lock of your mutex. And once this lock guard object is going out of a scope in its destructor, it will unlock. So is what I feel in my major use cases, this lock guard served all the purposes of locking and unlocking. There may be some specific use cases where you want to manually lock or unlock. That's a different scenarios, but your lock guard will save you with this. And by doing this, you will save your application to getting blocked. Okay. So this lock guard has no method other than constructor and destructor, and lock guard is not copyable. You cannot copy one lock guard object to another because that assignment operator is deleted here. So you cannot copy that. Keep that in mind. Now we have created we wrote one application which is printing your odd and even numbers, and you have we saw log guard, mutex, and lots of things. But is there any better way? Yes, there is. In C++11, it introduced stood atomic. I'm using int, that's why I have written int, but there are multiple things. Means you can pass it bool, you can pass it whatever data type you want to use it. Okay. So this atomic, this will make sure at a time only one operation can be done on this. One operation means one thread can access this variable or this resource. So that is what atomic do. And with this, you don't have to worry about synchronization. Language itself provide it as a synchronous way. Means you cannot do any two activities. You cannot read two threads cannot read and write at the same time. So it's safe. So in this kind of scenarios where you have one variable or one object, you can use atomic. That's means I use a lot this. So in this there is a thread yield function. If you see at line number 8 and line number 21, I'm using yield. So we'll also see that. So this is something which which I just said about atomic thing. Okay. Now this yield function, what this do is it will put your thread in a I'll say it will pause your thread temporarily, and it will allow to run your other thread, and it will wait till it gets whatever shared resource it is waiting for. Until that is not it is not getting, it will wait there, and it will not block other thread to execute. But if you will use sleep instead of yield, so sleep will block your thread, okay, and it will block your the execution for certain period of time, and then it will again it will wake up, and after some whatever time you are giving, 1 second or 2 seconds or 100 milliseconds, it will wake up, it will again check the resource, and it will again go to sleep. So it will block your thread, and yield will just pause, and as soon as it is getting its resource, it will start executing. In sleep, whether a resource is available or not, it will sleep. So let's say you have a 1 second sleep, but the resource is available after 500 milliseconds, but your thread will be sleeping there. But in case of yield, it will immediately start executing. Now we are coming to our next section of the talk, and that will see some common concurrency patterns, and we'll start with publisher consumer, very well known one. So here we are creating we are creating two threads. I omitted that main function, so I'm just showing you producer and consumer. These will be running as a thread, and in producer I'm I'm updating some values in my queue defined at line number 1, and in consumer I'm reading from there. Okay, so to do that I'm using condition variable, because what I want is I want my producer to notify my consumer thread whenever resource is available, some data is available. Otherwise, if if let's say we don't use condition variable, and consumer thread will continuously running and checking for for the new value entered into your queue, and it will consume your CPU. And there might be possibility that it will block, it will only continue, it will not leave your CPU to execute some other application or some other thread. So to avoid those kind of scenarios, we can use these condition variables where my consumer thread will wait on this condition variable, and I'm passing this lambda function here with the condition that if queue is not empty, if there is some data, this this will start executing, it will complete. And from my producer thread, I am continuously, I'm notifying when my producer thread will push some data into queue, it will notify to my consumer thread, okay, there is some data, go and start using that. Okay, and my consumer thread will use that data, consume that data, and before getting that, it will take lock and unlock thing will happen, and it will start working. So my consumer thread will not consume my CPU, it will not chew my CPU utilization. Okay. So in condition variable, we have notify one. So notify one will only notify to a single waiting thread, and notify all will notify to all the other waiting thread. And same way, you have three different methods: wait, wait for, wait until. So wait is a normal one, it will keep waiting till the time it is getting some notification. Wait for will wait till some duration, whatever duration you are giving, and it will wait for that time, and then it will time out. Okay. Now, in the previous program example, we saw there was one unique lock. I have used unique lock instead of lock guard. So the benefit is when you are using unique lock, you have a more control over locking and unlocking. You can unlock and you can unlock as per your convenience. But the added advantage is it is for transferring ownership. So if you want to transfer some ownership from one thread to another thread, if from one function to another thread, unique lock is your tool. So there is a difference, and this is the major difference. When you use unique lock, you can transfer ownership of your lock between different unique locks objects. You can pass it from one to another. Okay, means you can construct using one unique lock object using another unique lock object, and your ownership will be transferred to there. It is good when you are passing it to a new thread. That ownership you are passing to new thread, and the benefit is when whatever thread it is owning, it will clean that there only. You will not have to worry, okay, I have passed my control, my mutex control there, so now in this thread I'll have to, no, it's passed, it's done. Okay, but at the same time, lock guard, you cannot transfer that. We saw that operator, assignment operator is deleted there, so you cannot do that transfer thing. So this is the major difference. Now, the another pattern is reader writer problem. So you have two threads. One is reading from anywhere from database. Let's assume there is a shared database. So your one thread is reading from database, and other thread is pushing into database, some data into database. Now the thing is, if you are going with a unique lock, you will take exclusive ownership on the database. Now let's say there are 10 threads which are reading, and there is one thread which is writing. So your there are chances that your writer thread will not get lock at the time when it wants. That is important. So we have one stored shared mutex in our C++ library, what it allows is it allows to read the data simultaneously. But in this problem, reader writer, when you are writing, you should take a unique lock, exclusive lock on your resource. But when you are reading, you need not to take that exclusive lock, because just you are reading, you are not going to update there. So this is something which you can use, this combination of shared and unique locked in this reader writer scenarios. Another pattern or mechanism, synchronization mechanism, is barrier, where you allow multiple threads to do some activity on the resource, and or let them do reach to the some point, and then after that you will do something different. So it's not only one thread at a time, maybe 5 threads. You are allowing 5 threads at a time to work on. So means that is you can use this in C++20. We have counting semaphore, barrier, cyclic barrier. Today we'll not go into those things, but there are these things which you can use to achieve this kind of scenarios. With this, we are coming to our conclusion, and we are at the end of our talk. And here are some points. Means always use RAII, so use log guards and some that thread guard and log guard kind of things. And you can use condition variable for notifying to each other. And most important thing is always test your concurrent code thoroughly. Use some tools to identify the possible issues, to detect any issue or fix them, but do this very thoroughly, because if there is some issue, you will not get a direct answer, okay, why it's happening in multi-thread application. It's a little difficult to debug than a normal single thread application. With this, we are at the end. Here are some references which you can go through. I highly recommend this book, C++ Concurrency in Action. You can go and you can read this. It's a very descriptive knowledge you will have about concurrency. It's dedicated to that concurrency only. And there is article, means it's not article, it's series of articles on concurrency by Rainer Graham. So you can go through this link and you can read, and it's very well structured things are there about concurrency, about memory model. And there are these two very good talks. I usually go through these talks multiple times whenever I want to understand something. And if you'll go through these talks, you may feel that I took some ideas from them.